Tom, I have a customer who wants to put a 450 horsepower engine in their fire truck, and I would like to put a 2,000 gallon per minute water pump in it. Will I have enough horsepower for that big of a water pump?
Well, that's a great question, Kayla. Did you know that the term horsepower was adopted in the late 18th century by a Scottish engineer by the name of James Watt to compare the output of steam engines with the power of draft horses? It was later expanded to include the output power of other types of piston engines, as well as turbines, electric motors, and other machinery.
This is a horsepower math problem. Here's the formula, where HP is the horsepower required, P is the desired pressure in PSI, Q is the desired flow rate in gallons per minute, and E is the efficiency of the water pump.
Now let's jump into the numbers. Typical fire pumps have an efficiency of around 60%. The National Fire Protection Association requires the flow rate to be at 150 psi.
With all of those numbers, can you put the equation together?
So this is the formula and the solution.
So that means that we do have enough horsepower because we would only need 292 horsepower to run the water pump.
But what about the rest of the truck?
Good thinking. The last step is to factor in the other loads on the engine, such as the air compressor, the alternator, and the cooling fan. We are typically safe to assume that they will use 20% of the engine's power. So we need to find out what horsepower we have available for the water pump.
So that means that we have 360 horsepower available because available horsepower equals 450 times 0.8, which equals 360 horsepower.
Woo! Since we calculated that, we have 360 available horsepower, and that is greater than the 292 required horsepower needed to run the water pump. We can say that their engine should have enough horsepower to run that water pump.